2017 paper 1 sequences and series question. We're on question 7. The first 3 patterns in a sequence of patterns of tiles are shown in the diagram below. Part A, draw the next pattern of the tile onto the diagram above, and I'm sure you'll have no problem to do that. Based on the pattern shown, complete the table below, and I've done my table there. So that's fairly easy to do. Again, this is my first pattern, so this is T1 as such. Therefore, A is 5 in this case. And I would use the diagram here, the table here, to find out what my common difference is. And we can see it's plus 3 each time, so my common difference is plus 3. So part C, assuming the pattern continues, the number of tiles in the nth pattern of the sequence is given by the formula. The T of n is equal to Pn plus Q, where P and Q are elements of n. Find the value of P and the value of Q. This is similar to the last question, it's just a little bit easier. We're going to be using simultaneous equations again. So we use the formula given to equal the answers in the table. So I'm going to use the first pattern, T1 is equal to 5, and I know A is 3, and I know D is plus 3. So this is a simultaneous equation. We use the formula given to equal the answers in the table. So let's go with the first one. The T of n is equal to Pn plus Q, but I know that the T of 1 is 5, so therefore I say the T of 1 is equal to P1 plus Q, which is equal to 5, therefore P plus Q is equal to 5. Do the same for the second pattern. The second pattern, T2 is equal to 8, T2 is equal to 8, therefore P times 2, using the formula, the second pattern, n subbing in, plus Q is equal to 8, so I've got 2P plus Q is equal to 8. Taking this equation and this equation together, I now have simultaneous equations. So 2P plus Q is equal to 8 and P plus Q is equal to 5. So I'm going to multiply the bottom line by minus 1 so I can cancel out my Q's. So we have 2P plus Q is equal to 8 minus P minus Q minus 5 after we multiply by minus 1. 2P minus P is equal to P. The Q's cancel. 8 minus 5 is equal to 3. To find out what P is equal to, I'm going to use P plus Q is equal to 5. Sub in 3 for P. So 3 plus Q is equal to 5. Q is equal to 5 minus 3. Bring in your 3 over. Therefore, Q is equal to 2. The next part. How many tiles are in the 20th pattern? So the 20th pattern is T20. So we know that Tn is equal to Pn plus Q. But we also know that P is 3 and Q is 2. So I'm going to sub in 3n for P and 2 for Q. So we just want the 20th pattern, so that's fairly straightforward. T20 then is equal to 3 times n in this case is 20, plus 2, 320s are 60, plus 2 is 62. Find which pattern has exactly 250 tiles. Which n gives you 250? That's what they're asking for. So I know my formula is 3n plus 2, but the answer is 290, so we let it equal 290. So bring your 2 over. 3n is equal to 290 minus 2. 3n is equal to 288. Divide both sides by 3 to get n on its own. N is equal to 96. Part D. Show that the S of n is equal to 3n squared plus 7n all over 2 is a formula for the total number of tiles needed to build the first n patterns. So the total number of tiles means you've got a certain number of tiles and you can't break up previous tiles. You have to keep all the tiles there and you keep on making the patterns. So we know again from our formula tables that n all over 2 times 2a plus n minus 1 times d. Again, move your d in here. And we know from our table that a is 5 and d is 3. So we sub in n all over 2. 2 times a is 5 plus 3 times, I'm just putting my d over here, less chance of making a mistake, n minus 1. N all over 2 comes down. 2 5s are 10. Multiply out the brackets. 3n. 3 by minus 1 is 3. 10 minus 3 is 7. Bring down your n over 2 and bring down your 3n. Now again, how do we deal with this one? Some of you find that's a little bit difficult. I've just moved the 3 over n over here to swap them around so that it will look like the answer. That's the only reason I've done that. Okay, this time I'm going to bring the 2 inside the brackets first. So when we bring the 2 inside the brackets first, because 2 doesn't divide into 3 and into 7 evenly, and because I know that's the answer, I'm just going to say all over 3n plus 7, all over 2. Now multiply out your n. N by 3n gives you n squared, and n by 7 gives you 7n, and you now have the answer that they've given you. Okay, part 2 of D. Find the total number of tiles needed to build the first 30 passions. So the first 30 passions would be n is equal to 30. This means all the tiles added together. That's what the S means, it's the sum of. So we have our formula from up here, or the one that you got yourself, derived yourself. Sub in n is equal to 30 into n here and here. So we get 30 squared is 900. 7 30s are 210. That comes out as 2,910 all over 2, which gives you 1455. So what it means is you need 1,455 tiles are needed to make the first 30 passions if you don't break up any of the previous passions.